Hi everyone, in this tutorial we're going to go over the instructions for lab number 6, total internal reflection. So you will access the lab instructions in the folder labeled lab number 6 in Blackboard. So click on this folder and you will have access to the link, the PDF link to the lab instructions. And below it, you have the link for the submission of the completed report. So let's click on total internal reflection. So this will open up this window. And this are the worksheets or the lab manual or lab instructions. And right here is the link to the simulation page. The instructions for this lab are very straightforward, and the simulation interface should be familiar to everyone by now, because this is the third time or the third lab for which we're using this bending light simulation. So let's go ahead and click on the simulation link. I'm going to open it in a new tab. So the bending light simulation, and select intro. So this takes you to this familiar interface, and then you grab your protractor, align it with the normal line. 0 should line up with the normal line, and 90 degrees should line up with the boundary. And then you can press the light source to emit a ray of light. And here we have the intensity measuring tool. Medium number 1 here is air, and medium number 2 is water. So let's go back to the instructions. So the first part, or part A, step number 1 says go to the simulation and choose intro. Set it up so that it looks like this screenshot. So the top material should be water and the second should be air. So let's go back and switch this to water and this to air. Okay, so now our simulation looks like this. Proceed to step number 2. Gradually increase the angle of incidence to 40 degrees. And it should look something like this. Read off and record the angles of reflection and refraction. So basically move this to 40 degrees and then measure the angle of reflection, the angle of refraction, and record it in your worksheets. So take note, the light source can go from 0 to 90. Okay. Step number 3 says keep increasing the angle of incidence until the angle of refraction is as close to 90 as you can get it. Then, so see the crop section, so adjust it close to this setup. If you increase the angle of incidence further, then the refracted ray will disappear. So starting from here, if we keep going, you notice that at this point, right around here, the refracted ray disappears. So you're going to adjust your incident ray until you find the point where the refracted ray disappears. The angle of incidence for which that happens is called the critical angle. So you record it in the space that says critical angle for water, since the top material is water. Step number 4, return the angle of incidence to 0 and change the top material to glass, and repeat step 3. So return this to 0, change this to glass, and repeat the process until the angle of the refracted ray disappears. So the angle of incidence for which the refracted ray disappears for glass is the critical angle for glass. You write it here. Step number 5, repeat the process for mystery material A and B. So essentially go back, take this to 0, switch this to mystery A, and look for the angle of incidence for which the refracted ray disappears. And that should be your critical angle for mystery material A. Then switch this to B, repeat the process. So right around there. Now take note, I'm just illustrating. When you're doing the actual simulation, you have to be much more careful and change this very carefully to locate exactly where the ray disappears. And that will be your critical angle. Don't just read the values you see in my illustration, because I'm just illustrating. I'm not, changing it gradually enough to determine the critical angle. I'm just showing you roughly around where to expect the critical angle. So that's step number 5. Step number 6, you've determined the critical angle of glass, mystery A, mystery B. You're going to compute the sine of the critical angle, 1 over the sine of the critical angle. And as you can see in the first row, for the example, a sample calculation has been done for you for water. Critical angle is 49. Sine of the critical angle is 0.755. 1 divided by the sine of the critical angle is 1.33. The refractive index of water is 1.33. So what this tells us is 1 over the sine of the critical angle is equal to the refractive index of the top medium. So since you know the refractive index of glass, mystery A and mystery B, do the same calculations, and whatever number you get here will be the refractive index of those materials, and then you write your answers here. So for part B, we're going to study intensity. So step number 1 says change the top material to water. Bottom material should be air. So let's go back to water and air. And then so adjust the angle of incidence to 10 degrees. This is 10 degrees. And then grab the intensity measuring tool and place it on the reflected ray. Record this value in the table. And then increase the angle as shown in this table, 20, 30, 35, 40, 45, 50, 55, and record the intensities. Again, this is the intensity of the reflected ray, not the refracted ray. So once you've completed this table, step 4 says when the angle of incidence is greater than the critical angle, 100% of the light intensity is reflected. So this is called total internal reflection because all the light is reflected. So based on your measurements, suggest a value for the critical angle for water based on the recorded intensities. And so that completes the measurements for this lab. So you need to write a summary, that's your abstract using the template provided, and then your cover sheet, And that should be a lab report for lab number 6. If you have any questions concerning any part of this simulation, do not hesitate to email me.